Supply Chain Assistant is our machine learning-based product that navigates the replenishment process taking into account predicted product demand. The end result is the table that contains the amount of required refill for every product in every store. The required refill is estimated so that we have enough, but not too much, of the product until the following replenishment event. The table also contains the monetary value of the estimated optimal refill for every product in every store. The most important KPIs we take into account when optimizing the stock are the following. Stock out, or out of stock, events happen when a particular product is out of stock while there is a substantial demand for the product in question. This is a serious problem as we are missing out on potential profit every time a customer wants to buy a product that is out of stock. In the long run, this may even lead to losing customers. Overstock events happen when the amount of stock of a product in a store substantially exceeds the amount that can be sold within the following week, or some other replenishment cycle period. This poses an issue because we invested in large quantities of stock that we may not be able to sell before the expiry date. As well as that, these products might take up a lot of space in our storage that would be better used for storing the items that are more in demand. Industry and background. Chain stores such as pharmacies and supermarkets. Challenges for the retailers. Every chain store has the need for automation and optimization of the replenishment process in their retail wholesale objects. Replenishment is supposed to be optimized so as to primarily reduce the number of missed sales. It is also of great importance to reduce the amount of excess goods in the storage, particularly if the expiry date is short or if the product takes up a lot of space in the storage. Solution. The solution is to predict the optimal stock using machine learning. Based on that estimation and the current stock, one can plan replenishment. Tools used for analysis and problem solving. Machine learning algorithms as well as the replenishment algorithm that simulates the replenishment of every store with every product in its assortment. The replenishment algorithm is developed with respect to the client's specific needs. Another important part of the system is the visualization, which is a Tableau dashboard. The dashboard enables the clients to plan and keep track of the entire replenishment process. Differentum Specificum, a model that predicts optimal stock and with 99% probability determines the stock needed in a store so that there would not be stock out and overstock events. Results. Instead of hiring people to navigate the replenishment process, the solution is automated. Artificial intelligence continuously learns, so the changes in shopping habits are always taken into account. Measurable results on available data. The amount of missed sales has been reduced by 90% in pharmacies, which resulted in the reduction of the missed sales in the amount of around €1,000 per pharmacy per month. The amount of missed sales has been reduced by 70% in wholesale. The number of times the stock dropped below minimum mandatory stock has been reduced by as much as 98%. The estimated amount of excess goods related to overstock events has been reduced by 30%. How the solution works. Unlike traditional statistics, artificial intelligence can recognize dependencies between different types of data, structured or unstructured. For example, weather conditions, unstructured, affect sale of different products, structured in different ways. Traditional statistics would require supervision and input from an analyst in order to get the connection between the sales and weather conditions right. On the other hand, the artificial intelligence solution can work independently. Thanks to machine learning technology, the system has the ability to continuously learn and take into account the changes in the business process. The more data we have for training, the better quality results we can obtain. Therefore, the system is flexible, and our clients can be confident that the results are optimal and up-to-date, regardless of possible changes in the business process that may happen. Patterns and dependencies are quickly recognized by machine learning algorithms, and those are used for generating prediction results. There are numerous combinations of products, stores, and weekdays, often millions. Sales of many products are dependent on sales of other products. Sales of each product depend on specific combination of parameters and input data. For example, sales of water depend on temperature and precipitation. This makes for a large number of complicated dependencies, and the only way to recognize them and use them for better predictions is via artificial intelligence. Predicting optimal stock has always been a complicated problem. There is always a trade-off between the number of overstock and stock-out events, and it is particularly impossible to find perfect balance. However, as an example, we can specify how much stock-out we are willing to allow for and thus solve the problem with respect to the client's specific needs. For example, if we allow for a product in a store to be in stock out for only 1% of days within a specified time period, machine learning can come up with optimal stock that minimizes the amount of stock out while controlling the increase of stock, so as to control overstock at the same time. User experience. On the main page, the user can see his history of replenishments. Users can choose to filter it based on status, see the details of completed replenishments, or create a new replenishment document. For the new replenishment, users can choose the supplier, and the system automatically filters to show only the items from that supplier. Items can be added or removed easily. Users can add single items, whole categories of chosen suppliers, brands, or any combination of the two. Thus, just in a couple clicks, we can add our favorite chocolates for the replenishment. The process is even more automated for stores where the user has defined a supply schedule. There, every night, all the documents for replenishment are prepared, optimal stock generated, and the user only has to confirm and eventually correct the suggested optimal stock if he knows something that the algorithm doesn't. Thanks to integration with ERP for warehouse management or with central back-office software in the stores, prepared replenishment is easily sent and included in the standard ordering process in the company. Peculiarities of the supply process are very important, and that is why we have implemented all that we identified as mandatory. They include minimal stock, lead times, assortment, supply calendar, and expiry dates. Users can easily manipulate or import the data in these tables, and in that way we have even greater control. If some of those data sources can be found in the client's ERP or central back-office systems, our system can automatically refresh the data and use it. Machine learning-based replenishment versus classic replenishment. Comparison in Tableau dashboards. We compared the simulated replenishment process based on our machine learning model with the real replenishment process that actually took place, which was, on the other hand, navigated by a human. On the dashboard, we can see the comparison of the model simulation of stock, orange, versus the true amount of stock, blue, over time for a particular product in a certain store. The horizontal line represents the minimum mandatory stock for that particular product store combination. We can see that the model, orange, reduced the amount of stock when compared to the reality on certain days. On the other hand, on days when in reality there were missed sales because the stock dropped to zero, the model handled replenishment in a better way. Overall, the model simulation never missed a sale and furthermore never dropped the stock below minimum mandatory stock. On November 13th, clients supplied a large amount of stock which was sold immediately. The model had no knowledge of that event, so its stock quantity fell to zero. Model automatically increased the stock quantity afterwards to prevent future stockouts and slowly started to reduce stock when the increase in sales didn't happen again. Model reduces overstock on the observed item in the first few weeks, and then it maintains optimal stock. This selection shows the comparison of the model simulation versus real replenishment with respect to stock out. All the figures represent sums for all items and stores. We can see that the model quickly reduced the number of out-of-stock events. This selection shows the comparison of the model simulation versus real replenishment with respect to overstock. Overstock happens when we have too much of a certain product in stock. We can see that the model increased overall stock in the first few weeks to reduce probability of stock out for some items. As the model can only increase the amount of stock, it relies on sales to reduce overstock over time for items with large stock quantities.